Hello everyone, welcome to TIC. This is Kushal and today we will be looking at a very famous problem, longest palindromic substring. So let's quickly see what the question has to say. So given a string S, we need to return the longest palindromic substring we can find in the string S. Now for those of you who do not know what a palindrome is a word or a sequence which reads the same from front and back. Let's see. A, B, C, C, B, A. That was the front part. Now A, B, C, C, B, A backwards. Those are the same, right? So these are some of the examples of palindromes. Now according to the question, if we are given this string, we need to return either BAB or ABA, as they both are palindromes and they are of the length 3. So even if we return any of them, it's fine. But if I modify the string by adding DA, now the longest palindromic substring would be ADDA, because the length of the ADDA, which is 4, is greater than BAB length or ABA length, which is 3. Some more examples. So if you are given the string CBBD, the longest palindromic substring would be BB. If we are just given the string of length 1, A, we can return just A. For AC, we can either return A or C. Now, the brute force way of solving this problem would be to generate all the possible substring of this string, which are these, and then try to see whether they are palindrome or not. If they are, we'll just get the maximum length palindrome out of it. So, what will be the time complexity for this brute force approach? In order to generate all the possible substrings, the complexity will be n square, right? And then to iterate and check if those are palindrome or not, another n. So in total, the time complexity will be O of n cube. Now let's see how we can use dynamic programming to optimize this approach. Now we're going to try and write our DP approach on the string that you can see above. For that, you need to make a 2D matrix where the width and the height of the matrix is equal to the length of the string given, which is 7. Now consider that the numbers on rows or the y-axis are the starting index of our substring, and the numbers on columns or x-axis are the ending indexes of our substrings. Alright, so we're going to start considering our substrings with length 1 and slowly, gradually increase it up to n. So let's see what will happen for the substrings with length 1. If we start our substring at index 0 and also end it at 0, we will consider this character, right? Just this character. And we know that the strings with a single character is considered a palindrome. So we'll just write 1 over here. Similarly, if we started at 1 and ended at 1, we'll consider this A character, which is also a palindrome. So if we consider all or any single character, that will be palindrome. That means the whole diagonal of our matrix will be 1. So we considered all the string 1, length 1 substrings. Now we'll consider all the substrings with length 2. Now, in order to determine whether a substring with length 2 is palindrome or not, we just need to check one condition. If the starting character and ending character are both the same, then it will be a palindrome. Let's see. So the first substring will be with starting index 0 and ending index 1. As both of them are same, AA, we can write 1 over here. Similarly, second substring starting at 1, ending at 2, and as both of the characters are same, we can write 1 over here. 2, 3. As A and B are not the same, we can write 0 over here. 3, 4, BB, again, those both are same. So 1 over here. 4, 5, 4, 5, BA, not the same, 0. 5, 6, same, 1. Now for substrings with length 3 and onwards, we're going to come up with a condition check. Please pay attention here. For example, if we have this string ABCBA and if we need to check whether this is a palindrome or not, we can have two checks over here. The first check will be whether the first character and the last character are same or not. The second check will be whatever is between the first character and the last character, whether that string is a palindrome or not. Now how do we check whether the string in between is a palindrome or not? Now let's consider our first substring with length 3, AAA. Here the first and the last characters are same. Now how do we check that the substring in between them is a palindrome or not? Can we just check DP of 1, 1 as the substring starts at index 1 and also ends at index 1. To generalize, we need to check two conditions. First, if the character at the first index and the last index, if both of them are same, and dp of I plus 1 and j minus 1 is also 1, then the substring that we're considering is also a palindrome substring. Alright, now that we know the conditions, let's quickly dry run this whole thing. So the first substring with length 3, AAA, as we came to know that that's palindrome, we'll put 1 over here. Now second one, which starts at 1, ends at 3, AAB. Now as the A and B are not same, we can just put 0 over here. Second one, third one, which starts at 2, ends at 4, AAB. Again, the first and last character are not same. 0, 3, 5, DBA. Again 0, 4, 6. BAA. Again, first and last character are not same. We'll just put 0 over here. Now we'll start considering substrings with length 4. First substring will start from 0, will end at 3, AAAB. Again 0. Second one starts at 1, ends at 4, AAAB. Again 0, 2, 5, AA, AB, BA. Now the first and last character are same. That means first condition satisfied. What do we need to check now? As it is 2 and 5, we need to check dp of 3 and 4, which is 3, 4. As the second condition also satisfies, we can put 1 over here. Now the next substring starts at 3, ends at 6, BBAA. Again, first and last characters not same, we'll put 0 over here. Now we'll start considering substrings with length 5. First one starts at 0, ends at 4, 0 to 4. First and last character not same. 0, 1 to 5. Same. As the first and last characters are same, the first condition satisfies. Now we need to check the dp of 2 and 4. 2, 4. As it's 0, we'll put 0 over here. Now 2 to 6. 2 to 6. First condition satisfies. Now we need to check 3, 5. 3 and 5. As it's 0, we'll just put 0 over here. Now we'll see the substrings with length 6. First substring will start at 0 and at 5. 0 to 5. Alright, both of them are same. First condition satisfied. Now we need to check 1, 4. dp of 1, 4. As it's not 1, we'll write 0 over here. Second one, it will start at 1, will end at 6. AA, BB, AA. Alright, so first and last character same. First condition satisfies. Second condition, dp of 2 and 5. dp of 2 and 5. As dp of 2 and 5 is 1, second condition also satisfies. So we'll write 1 over here. Alright, the last substring with length 7, the whole string, starts at 0, ends at 6. First and last characters are same. First condition satisfies. Second condition, dp of 1 and 5. 1 and 5 is 0. So we'll write 0 over here. Now, how do we get the longest substring? So while making this table up, we can keep track of the starting and ending variable. Whenever we put a 1 in a matrix, we'll check if the substring that we are making, if it's greater than the previous substring, we can change this start and end to a current I and current j, and in the end we can get the substring from our original substring of starting at I and ending at j. Okay, let's quickly code whatever we discussed on the whiteboard. For the base condition, if my s dot length, if that equals to 0, then I can just return an empty string, right? Alright, let's quickly take the size of the string, and then we will form a dp matrix. Integer, 2D integer, dp is equal to new. The width and height are going to be equal to n. Now let's quickly fill the matrix for length 1 and 2. For that, let's have a for loop starting from 0, and we'll let it go till n, I plus plus. So the diagonal of the matrix needs to be 1, right? dp of I comma I is equal to 1. For the substring with length 2, we can have a j pointer, which will be I plus 1. Now if my j doesn't get out of bounds, if less than dp of 0 dot length minus 1, and we also need to check if the first condition of the first character and the second character are same. So s dot character at I equal to s dot character at j. If that's the case, we can have dp of I and j to 1. So we just check the substring with length 1 and 2. Now we will check for the length 3 and onwards. Alright, the out of bound condition is not going to be -1. Just j is lesser than dp of length. Alright, so we also need to have integer max length in the beginning, which will be 0. Start and end pointer, just as we discussed, right? Integer start 0, integer end 0. Alright, so we will start our loop with k is equal to 1. This is going to be the length, okay, k less than n and k plus plus. Okay, for each length we will have a starting pointer I from 0, I less than n and I plus plus. Now the ending pointer is going to be j is equal to I plus k. Alright, so here we're gonna check those two conditions, right? But before that, if our j gets out of bound, if that's the case, we'll just continue. We will not go further in this iteration. Okay, the out of bound condition is going to be j greater than or equal to dp dot length. Okay, so now we're gonna check those conditions. If s dot character at I, if it's equal to character at j, the first condition, and the second condition, dp of I plus 1 and j minus 1, if that's equal to 1, then we can make this dp of I and j as 1. And whenever we are changing this dp of I and j to 1, we need to update our start and end pointer, right? If my current max length, if it's lesser than j minus I, which is the current length, we can update this max length with j minus I. At the same time, starting pointer will be I and ending pointer will be j. So there goes our length loop. Now after we are done with this loop, we just need to return s dot substring, which starts with starting pointer and ends with ending pointer. The substring function doesn't consider the last index, right? Okay, so this is about right. Let's try to run this code. Alright, gives us the right answer. Let's try to submit it. Awesome. So our solution is faster than 14% of the solution. Not that bad, right? Okay, so what will be the time and space complexity for this approach? Compared to the, getting all the substring approach, here we are just considering our DP matrix. So time complexity will be O of n square. What about space? So as we are storing nothing but our DP matrix, the space complexity will also be O of n square. Alright, that's it for this question. Thank you everyone for watching. Please like, share and subscribe.